All right, so good morning. Welcome to session 6 on UGBS 202. All right, so today we'll have a quick lesson on decision variables. Sorry, not decision variable, mathematical modeling. And in learning about mathematical models or modeling, we would understand or learn to identify what decision variables are, know what an objective function is and what constraints they are, and then how we represent constraints with linear equations and inequalities, okay? And also put all these concepts together to represent a mathematical formulation, a mathematical model that has decision variables, an objective function, and then a set of constraints, okay? Now, why do we need to understand these concepts of mathematical modeling? The understanding here is in real life situations, there are complex business problems or complex business life problems that we always see to make decisions on. Now, generally, businesses seek to make two sets of decisions. They are either seeking to maximize a certain parameter or they seek to minimize a certain parameter, okay? So in how do you call it, in deriving a certain mathematical model, the aim is to ensure that we come out with a certain decision, okay, or come out with a certain solution that optimizes our objective. In the terms of optimizing our objective, it means that, well, if we are seeking to make profits, then our solution should give us the highest possible profits. If we are seeking to minimize a certain situation or a certain problem, then our solution should give us the least possible alternative, or that's what we call the optimal solution. So let's look at, say, a typical example where you are producing a certain output or certain product, maybe 2 or 3 products, and you wish to sell them for a certain amount of money. Now, at what, maybe how many of each of these products should I produce to get the highest possible profit? That is a decision. So you look at it from the sense of profits or revenue, more is always preferred to less. So when a business has an objective to maximize a certain parameter, we are looking at stuff like profit, we are looking at revenue. Okay, these two parameters are mostly maximization problems. If you also have certain minimization problems, then we're looking at stuff like cost, distance, time. Okay, these are all parameters that we seek to, that we usually would seek to minimize. So for instance, think about it. If you were moving from Legon to, what's it called? You're going to Legon and then Accra. Now, if you were to pick public transport for, let's say, 5 cities, and someone were to give you a lift, all things being equal, it is safe to give to board to take a lift. They're not going to harm you, nothing. All things being equal, I'm sure 90% of us will choose the option of the lift to Accra than to pay 5 cities to Accra. The other part of it could also be, well, suppose that you have Ayalolo that will take 2 cities from Legon to Accra. And then you will also pick the normal transported trotro that will take 4 cities. Given the chance that all things being equal to be comfortable and what a chunk of us will pick the bus, the government bus, compared to the private proto bus. Okay, so all these are decisions we make day in, day out, and then the idea is to minimize our cost. If you're going to Accra and you want to consider what is the shortest possible distance I can use to get to Accra, or sorry guys, I got kicked out. All right, so yes, so again, so I was saying, if you're probably going to Accra or something, if you want to find out, so which is the route that I would use that has the least traffic that would give me the least possible time to want to get to Accra. So if you selected 3 routes, one will take 20 minutes, another will take 40 minutes, and another will take an hour and a half. Obviously, a lot of us will root for 20 minutes option because it minimizes time. So these are the decisions that businesses always make in case of stuff. If you're even assigning, what's it called, employees to a task, you want to assign the least possible number of workers to a place and get the maximum output out of them as much as possible. All right, so with all these problems, we seek to use mathematics, to use math to solve these problems and come out with concrete solutions. And so we apply the issue of mathematical modeling or mathematical formulations. Okay, I hope the motivation is clear enough for all of us. So a business mathematical model is a mathematical representation of a worded business problem. For business problems amenable to mathematical representations, a mathematical equivalent or formulation of the problem enables a richer analysis than the worded equivalent due to its clear, concise form presentation. So we're saying that a business problem that lends itself to mathematical representation, the kind of problems that we can easily represent mathematically, gives us some added advantage. It makes it easier, richer to analyze and then come out, especially to optimize the problem. Okay, so now in mathematical modeling of formulations, the first thing we seek is to identify what we call our decision variables. Decision variables. The decision variables, again, are those elements in the mathematical model we seek to find the solution for. In fact, they are the reasons why we are actually doing the mathematical models. So oftentimes we call them the unknown variables in the mathematical model. Okay, so let's understand. Let's see how we define a decision variable, and then let's see what it makes happen. So an example says, imagine you have 10,000 to invest in 2 assets. Your concern is how much to invest in asset 1 and in asset 2. It could be anything depending on other information at hand. However, our concern is how much? How much do I put in asset 1 and asset 2? So for instance, you could put 1,000 in asset 1 and 9,000 in asset 2. Who cares? It's your money. You can decide to. Or you could also choose, depending on other information, to put 6,000 in asset 1 and 4,000 in asset 2. So all these are decisions. But how making this decision out of your guts, or probably saying, oh, I feel like this, or some of you are so very religious, a prophet will tell you, okay, so invest 3,000 in asset 1 and 7,000 in asset 2, and you also go and do it. Okay, so, well, in the case of math, we see that, how about let's represent this as a mathematical problem and try and optimize it and solve it and see whether it does work. So here, well, please, I am not denying the fact that a prophet can tell you where to invest and you can have. It's just that lately the kind of prophets we have in the country, they are so hopeless that you can't really even trust them anymore. So it becomes an issue of, it's like you become a laughing stock when you're talking about prophet of late nowadays. So let's say, because our concern is how much to invest in either of the assets, we can say, let X1 be a variable that represents the amount we will invest in asset 1, and let X2 be a variable that represents the amount we invest in asset 2. So what we have done is to define our decision variable. So we are going to make a decision on X1 and X2 to say that if we know what X2 and X1 would be respectively, then we can tell how much, what our investment is going to be. So if we have successfully defined our decision variables, then we can actually state the first part of the question, which is, if you have 10,000 cedis and you want to invest all the 10,000 in a certain asset, or you just want to invest 10,000 in a certain asset, how do we state this? We can say that X1 plus X2 is less than or equal to 10,000. Now, why would we use 10 less than or equal to 10,000 and not equal to? So now, this is where we want you to understand that you have same linear equations in high school. We are getting into the case where we want to combine both the linear equations and linear equalities and linear inequalities together in one mathematical problem, because normally real life issues always have constraints, or real life business problems always have certain constraints, and you will see them as we go forward. So for instance, if I have 10,000, the fact that I have 10,000 doesn't mean that at all costs I must invest all my 10,000 cedis. Someone will be willing to invest all the 10,000. Someone may be willing to invest some of the 10,000. However, irrespective of whatever the decision is, we cannot invest more than 10,000. All we have is 10,000 cedis. And so X1 plus X2 must be less than or equal to 10,000. So meaning that here, we can invest all the 10,000, that is the equal to part. And then we can invest less than the 10,000, which means in the case where we decide not to invest everything, we invest part, we still satisfy the condition. But we cannot satisfy the condition where we invest more than 10,000. Now, so the symbol less than or equal to reflects the fact that it is possible less than 10,000 could be invested in the two assets. Okay, and that makes absolute sense. For instance, if you're investing in Ghana at the moment, if you look on the stock exchange markets, day in, day out, the changes, the week. Does anyone trade stock in the class? Anyone can share views on? I usually try to check oftentimes to see whether you'd have certain firms of interest for us to. You'll see they're performing very marginally. And so it seems very, very risky. If you had a certain sum, let's say you had 500,000 cedis, and you're just going to spend all of them investing in some of these companies, you may wake up one day and out of the shock, you just pass out, and that's it, you are dead. So with these kind of things, it makes common sense at some point that yes, I have a certain sum of money. Yes, I'm willing to invest this much. However, I am willing to invest all of it, considering the case where all the, what's it called? All things being equal, the options I have available are viable or that viable. Okay. All right, so let's look at another example. A company manufactures products A and B using machine 1 and 2. Okay. Suppose machine 1 is available 60 hours a week and machine 2 is available 80 hours a week. In addition, to produce a unit of product A would require 2 hours on machine 1 and 4 hours on machine 2. Whereas a unit of product B would require 1 hour on machine 1 and 2 hours on machine 2. In a problem such as this, the challenge is to decide how many of product A and how many of product B to produce into. So oftentimes with these questions, I usually please advise that let's use the old school way of doing things, okay? Put it in a table form. It makes life easy for you. You will just easily. So we have product A and product B, okay? And let's have machine 1 and machine 2, okay? So it says that machine 1 has available hours of 60, machine 2 has available hours of 80, okay? So now let's get into the details. It says, so in addition, to produce a unit of product A, it requires 2 hours of machine 1. So product A, 2 hours of machine 1, and 4 hours of machine 2. You see? Then whereas to produce a unit of product B, it requires 1 hour of machine 1 and 2 hours of machine 2. Okay? So you see how life makes it easy. Once you have this, you just pick your stuff horizontally, you have your mathematical expression. And it says that you have, suppose, so here you've been able to represent this information. Let's just have, what do we call? Let's just define our decision variables. We can say let A be product A and let B be, or let's say XA be for product A and XB be equal to product B. Okay, so here the equation here is just written just as we have here. For product A, we need 2 hours of machine A plus 1 hour of machine B, machine 2, okay? Now, it says that the machine is available for 60 hours, which means that we can never do more than 60 hours. We can do up to 60 hours. We could also do less than 60 hours. So here, the only slice on you for you to understand this in this point and think into it and say that here we would use less than or equal to 60. Okay, and then the second one you can also have 4xa plus 2xb would also be less than or equal to 8. Please, for these ones, no one tells you. Okay, so this is like you applying your own ability to reason to come out with these inequality designs to write your stuff, okay? And please, to excel in this mathematical modeling stuff, a lot depends on your ability to think. And this is where I really like to stop a lot of my questions, because in this instance, this is the only way you can actually get the student to really think outside the box. You cause them to play scenarios in their heads, and they get to reason without memorizing formulas and all this kind of stuff. Besides, even in the exam, we give you the formulas. So all the other things, you probably just look into, you just need to remember what formula you apply. But with this kind of stuff, you get to think and you think analytically. And I like this kind of stuff. So lots of my questions that I would supply to my other colleagues for exam and IS usually will be around these for you guys to think, and come up with an answer. All right, so there are certain conditions or certain things that are very necessary when you are dealing with your mathematical formulations. The first is to define your decision variable. The second thing is to determine the right equality or inequality to use. There are certain times you have a blend of them. You may have linear equations, you may have linear inequalities all into the same set of problem, okay? Maybe a constraint could be equal to, another constraint could be less than or equal to, another one could be greater than or equal to, could be anything. All right, so a typical linear equation looks like this: the variable, the decision variable, and its coefficient, L and whatever number equals to the parameter. All right, so equal to a parameter. So let's look at an example here again, and let's see how you guys will think about it. A company earns a before tax of 100,000. Sorry. So this, so this is the before tax. This is their income before they are taxed. It has agreed to contribute 10% of its after tax to the Red Cross Relief Fund. It has agreed to contribute 10% of its after tax to the Red Cross Fund. It must pay a regional tax of 5% of its profits after the Red Cross donation, and a state tax of 40% of its profits after the Red Cross donation and regional tax. How much does the company have to pay in regional tax, state tax, and Red Cross donation? So here we are interested in just you giving us, you giving the expression. Now, I also need you to understand, please don't be too bothered. For now, don't be too worried about the actual solution. Here, our interest is for you to formulate the problem. Okay, so no one is going to give you a problem asking you to solve it. Maybe solve the simultaneous equation and all that. Next semester, when you're doing quantitative methods, we are going to have more complex problems, and we are going to use graphical methods, simplex methods, and even the computer solution. Now, in the day and age which we are, nobody solves these kind of problems or these real business problems with manually. So the idea is for you to understand these problems, and then we model them and put them into a computer, Excel or some other solver or something, and then get it to generate a solution for us. So this is just an introductory to that one. come in. So let's first start. This is so the first thing we do is to define our decision variable. We say so let R, S, and C represent all those things that we need. So R for regional tax, S for state tax, and C for Red Cross contribution. Okay, C for Red Cross contribution. So what does after tax means? After tax is your net, and after tax means your income that is left after all the tax components have been taken out of it. So if they've earned 100,000 and there are two main taxes, the regional tax and then the state tax, then after tax is going to be 100,000 minus the state tax plus the regional tax, which is again like 100,000, okay, minus the state tax minus the regional tax. This is all the same because this negative sign here redistributed across. So if the first thing says it has agreed to pay 10% of its after tax to the Red Cross Fund, it means that 10% of whatever is left after we have taken out the regional tax and then the what's it called? The state tax and then the regional tax, whatever is left, 10% goes to the Red Cross Fund. Okay. And another one says that it's supposed to pay a 5% regional tax after it has made the contribution to the Red Cross Fund. So here, the 5% is 0.05 into bracket the 100,000 minus the Red Cross contribution. Then it also says that it would pay a 40% state tax after it has made its commitments to the Red Cross and then the regional tax. Okay, so you see, these are just, and the state tax of 40% of its profits after Red Cross donation and regional tax. So you see, this thing is quite interesting stuff that you get to, you know, think into the problem and then rewrite the problem in a mathematical form that would help us solve it. All right. All right, so I think we're here. All right, so well, if you try to solve it, you probably will get stuff like this. You can start by first redistributing this, okay, and you can make C the subject and substitute and redistribute this, substitute C into this and solve for R. Then you can take R and substitute it into this and solve for S and you see what you want. But we are not interested in finding what the value of this is. So, you know. Now, so another question is Smith Company would like to know the total sales units that are required for company to earn a profit of 150,000. If the unit selling price is 50, the variable cost per unit is 25. See this, the total fixed cost is that. So we want to know the total sales units. So please bear this in mind. We're interested in the total sales units. Total sales units. Now, if you look carefully into all this, you notice we've been given the profit value, we've been given the selling price, okay? And we've been given the variable cost per unit, we've also been given the, and so we know that profit is total revenue minus total cost, okay? And we've also, so we know that this is price times quantity minus TVC, total variable cost, plus total fixed cost. Okay, so once you have these, you have this in mind, you can easily solve this expression, okay? So here you can redefine this. We don't know Q, in fact, that's what we're interested in. We know the selling price is 50, so our total revenue is 50Q. This is total revenue. Total cost would be our variable cost. Variable cost is going to be your production cost per unit, okay? So, and variable cost is a function of the unit produced. So whatever you have there is going to be your 25, which is the variable cost, times whatever number of units, plus the fixed cost, which we have as 500Q. Okay, so once you have this, so all you just need to do is to do your 50Q minus 25Q, okay? Then you see, when I put, let me put this into a big bracket. So plus 500K. So you agree that this negative affects everything and so on. So you have everything like that, and you can easily solve for Q. So Q become 26,000. This is straightforward, easy stuff. Again, you can also have similar problem like this. These are just basic problems for you to just think into stuff. So you can, here we are not, the emphasis, forgive me, but please, I want to emphasize that for this semester, the emphasis is not on finding the final answer. So it's not of interest to me. My interest is mainly around just up to this point here, where you are able to model the problem. So you're not going to have questions like this. I'll be asking you to find what the actual price of stuff will be in an exam. It will be mainly to formulate the problem. All right, so let's get into linear inequalities when we actually apply the inequalities here. And inequalities come in the form of greater than or less than or equal to. Okay, these are many. And then the equalities are this, is equal to. Oftentimes when you read business problems and you find words like at least, not less than, the problem is talking about something greater than or equal to. Okay, and then at most, when you have stuff like at most, when you have at most, you're looking at stuff like less than or equal to. We'll see similar examples. And then exactly, should be, must be, equal to. Okay, so you look out for these words in problems and it helps you to make out your formulations easy. So a person wishes to invest 20K in 2 enterprises. So the total returns for the year would be at least 1440. One enterprise pays 66% and the other one pays 8%. How much must be invested? So the first thing is define your decision variables. Always define your decision variables. Let's see, X1 and X2 be the amount to be invested, okay? We let X1 and X2 be the amount to be invested. This are we okay? Now, once you have defined your decision variables, you can use them to find whatever you want to do. So here I have 20,000 and I wish to invest 20,000. Says a person wishes to invest 20,000. So here there's no room for any of this thing. He wishes to invest 20,000. X1 and X2 must be equal to 20,000. But then he says that the total returns, okay, the total returns on both investments, okay, must not be less than 140, which is the same as must be at least. When you say at least, it means something or more. You get it? So yeah, so here, what's it? The stuff pays 0.66% is 6% means 6 divided by 100. Here is 0.06. Okay, so it's X1 plus 0.08 X2 must be at least 14. Okay, please have that in mind. And so now let's get into a proper business problem. Okay, so well, I have spoken about this, so we don't have to. Notably, businesses have these objectives. They either want to maximize profit or minimize cost, revenue, time, distance. So let's look at a question like this. It says a bank is attempting to determine where its assets should be invested during the current year. At present, 500,000 is available for investment in bonds, home loans, auto loans, and personal loans. The annual rate of return on each type of investment is known to be 10, 16, 13, and 20 respectively. Okay. Now, to ensure that the bank's portfolio is not too risky, the bank's investment manager has placed the following restrictions. It says the amount invested in the personal loans cannot exceed the amount invested in bonds. The amount invested in home loans cannot exceed the amount invested in auto loans, and no more than 25% of total investment, maybe in personal loans. So these things that we call restrictions here, in our modeling, in the mathematical modeling, we will call them constraints. Okay, so restrictions is the same as constraints. I believe we have all had this instance or this situation in economics which says that human wants are unlimited, but our resources available to satisfy those wants are very limited, right? So in every instance, we are all limited one way or the other by a certain situation. Well, if you come to school, you have a certain limited amount of money on you. You wish to spend, you wish to buy all the iPhone products, you wish to be wearing all the nice clothes, all the new designer clothes, you want to be looking flashy, but definitely it gets to, there's always that limitation of the resources, okay? Even if you have a car on campus and you have your tank filled, definitely you will get to a point where the fuel will get finished, and so you may have your tank will soon become empty. All these things are limitations. Now, limitations are everywhere in life. So we always need to work with limitations, or what we call constraints. Now, it is as a result of these constraints that is why we seek an understanding into mathematical modeling, because with these constraints, we seek to maximize our output or our decisions based on these objectives. If I have 1,000 cedis and I want to start a business, I want to sell 3 things. I want to be sure, or I have 1,000 cedis, I want to make an investment in 3 options. I want to be sure that at the end of the day, I am selecting the investment that would give me the highest possible return on my investment or my principal. So these are the decisions that we have to make. We make these decisions, so we try to optimize our decisions because of these constraints, okay? So it says the bank's objective is to maximize the annual return. Now look carefully at this word, maximize. Okay, so I told you there are 2 main objectives. Either we are seeking to maximize or we are seeking to minimize, okay? All right, so this is the form in which a well-designed mathematical model comes. First, we have a definition of our decision variables, where we say let x1, x2, x3, x4 to whatever number, depending on the number of variables we have or elements we have, be the amount invested in bonds, so bonds being x1, home loans being x2, auto loans being x3, and personal loans being x4, okay, respectively. So that is us defining our decision variables. Now, the objective is how much returns are we getting from each of these investments? So we are getting 10% on bonds, 16 on home loans, 13 on auto loans, and 20% on personal loans. So in stating that objective, we use the profit function or what we are gaining, either the profit or the cost function to state the elements to state our objective function. So here, the idea is our objective function is a maximization problem. 0.1x1 plus 0.16x2 plus 0.13x3 plus 0.2x4, which is saying that if we find what the values of x1, x2, x3, and x4 would be given the restrictions, this objective would give us the highest possible investment or the highest possible return we can make from the investment. The next thing is to try and state our what's it called, constraints. So we start. The first constraint is about the amount we have to invest. Left to us human beings, ideally, you would wish to have a huge amount of money, like unlimited. But guess what? The bank doesn't have that luxury. You know, people, the monies that the banks are investing, and well, this is just how they make their money or they make interest. That's how can they pay their people fat salaries. You go put your money at the bank uses it to do business or invest it with other people or other investors and get a profit. So the bank, you have a savings account that earns you 3%. The bank uses your money for business that earns the bank, let's say 13%. When it comes, it pays you your 3%, it keeps 10%. That's how just the world works. So, but you do notice that people will be coming for their deposits, they'll be coming to make withdrawals and all kind of stuff. So you must try to be in the balance. We can't invest all the money to people. Otherwise, when people come for withdrawals, we won't have cash to give them. So you must strike a balance. Let's take a certain amount and we'll be doing the business with, whilst we keep the remaining to run things in the bank. When people come for their monies, they can get their monies. So that is a constraint. So here we are saying that of all the 4 investments, X1, X2, X3, and X4, all 4 cannot be more than 500,000 cedis. So, but it can be equal to 500,000 because that is what we have arrived at. But and could also be less than 500,000, but it can't be more. Then the manager says that the amount invested in the personal loans cannot exceed the amount invested in bonds. So personal loans X4, bonds X1. We are saying that we cannot invest more in personal loans than this, which means that, but listen, think about it carefully. It says we cannot, it said cannot exceed, but it didn't say it cannot be equal to. So a lot of you may be confused in this case and just going to use less than, but it says it cannot. That's why I like this thing, because it helps students think outside the box. When I say something cannot exceed something, it doesn't mean that it cannot be equal to it. It can be equal to it, it can be less than it, but it cannot be more than it. Okay, so here it's X4 is less than X1, X2 is less than X3 because it was a similar caveat that was given. The amount invested in home loans cannot exceed. And then no more than 25%, no more than, not more than 25% of the total amount invested may be in personal loans. So again, we cannot invest more than 25% of our 500,000 in personal loans. That's all that's saying. So you put all this together and you have your mathematical volume. And then there's one last constraint. We refer to it as a non-negative constraint. The non-negative constraint tells us that whatever solution that we are going to have cannot be a negative solution or cannot be a negative stuff. Now, oftentimes students forget to put this. This is like a very important caveat. Now, most of the time you need to force the computer to give you a certain solution, because when you put in the values into the computer, it works, it does the iterations, and wherever the points converge, it gives you the value. So it can even converge beyond 0 and get into the negative, and it still believes that it is the right answer. So you must find a way of telling the computer that, well, I need only positive values, the optimum, the best possible positive value. The understanding here is that we are looking for an optimal solution. And the optimal solution must be a positive solution. So this is where we state that for this thing. Imagine you putting this information in Excel, and Excel telling you invest minus 100,000 in let's say home loans. What is 100 minus 100,000? So you would have to make sure that you suppress the parameters or give the computer also some constraints and say that the answers you're giving me must always be within positive scale. So we're saying that the last part of the mathematical formulation is very important, since we don't add this, we implicitly assuming that we can invest a negative amount, which is not possible. So, well, the second statement is only a little observation we have made, and so we just put it. So students who lose marks and all that in the non-negativity constraints for problems that seem obvious, negative amount is not possible. First, you how many of a certain product to produce and that kind of stuff, and you give me negative number. It means you're not serious. Okay. So the complete mathematical model oftentimes will look something like this. It says maximize this function subject to, ST means subject to the constraints, x1 plus x2, stuff that, and that, and that, and that, and then your non-negatively complex. Okay? We would see, we'll solve, we'll be doing the solutions when we get to quantitative methods, and that one would treat more of the heuristics there. All right, so this is session 7. It's on index numbers. We'll try and understand what's the use of index numbers, what's their purpose, how we calculate simple index numbers, what the base period is and when base periods are changing, and then what the simple aggregate and mean aggregate, and then we'll look at the mean weighted or the base weighted indices, and if time permits. So oftentimes in economics, we have a way of trying to represent information in a more meaningful manner, meaningful and easier manner that would help the average person or the individual to actually understand certain things. Now, suppose that our GDP, our GDP could have values such that 15,941,00. Okay, and let's see 8,431. Okay, now let's assume this GDP between 2020 and 2019. So you want to understand, you ask someone, so maybe you ask the national statistician and say you are like, so what is the growth rate of our GDP? Or what was the growth rate of our GDP between 2020 and 2019? And they said our GDP in 2020 was 15,941,800 and something. And in 2019 it was 8,409,700,000. It is often quite difficult to make sense of raw values or raw values of certain indicators when we do not find a way of presenting them in a more let's say in a more presentable way. Okay, so first, index numbers package such horribly looking numbers or difficult to understand concepts like this into more simpler and meaningful forms that helps the average person or helps to aid in understanding. 2, we are always interested in the rate of change between two elements or two variables or two or more variables. It could be time, it could be actual entities. Indices or index numbers helps to allow us to also present the rate of change between two or more variables, okay, over a certain period of time, okay, for easy assimilation and better understanding. So let's get into it and understand how we apply index numbers. So think about it this way. Let's take a basic example. Suppose that in January, canned Coke was being sold at 2 cedis. Then in February, it went to 2.2 cedis. And then it again increased to 2.8. Now, if I were to ask you, so what is the change in the price of say, Coke between January and February? Someone could just say, well, Coke was 2 cedis in January, now it's selling around 2.2 cedis. So that's it, that's the change. That information with the raw value doesn't really make so much sense. However, if we find a way of presenting it in a way that gives a more aggregated view of the situation, it's easier to understand and appreciate. So for instance, if I were to tell you that between January and February, there was a 10% increase in the price of Coke, it makes certain numerical sense. Look, on the average, if you go to the market today and the cup of sugar was 2 cedi, maybe the last time you went to the market, and today you go to the market and tell you, boss, sugar there is unreal. So rather the cup of sugar is 2 cedi 80 pesos. In the interim, you may not really see 2 cedi difference. It's only 80 pesos. You won't really see the difference, okay? But if someone to tell you, do you know that the price of sugar has increased by 40%? You go like, what? 40%. It was the same thing you went to buy from the market, which was sold to you at 2.8 cedis, but you didn't really see that difference. So oftentimes, index numbers help to bring a clearer picture, a clearer view, or make it more concise and easier to understand these concepts. That's why you have things like indices like inflation, consumer price index, GDP indices. All these things are presented in index number form to help our understanding. So you would always hear that they say there is inflation is, you would say that there is a 6% inflation rate, there is a 10% inflation rate, and it gets to understand that, oh, okay, so prices of goods and services generally on the market are increasing at the rate of 10%, 6%, 5%. It makes more sense, okay? So how do we find this percentage difference or the percentage point difference in prices or quantities or whatever? Oftentimes we take the difference. So the simple calculation of index numbers here is that we take the difference between the price changes and divide by the period against which you're trying to do the comparison. Now, in index number theory, the period against which we are making the comparison, we refer to it as the base period. So going forward now, we'll be referring to this as base period. So for example, if I am comparing prices or the price of Coca-Cola in January to the price of Coca-Cola now in October, then January would be my base period or my base month. And the price of Coca-Cola in January would be the base price or the base value of Coca-Cola then in January. Then the period which I am comparing January with becomes that new or the current period with a certain price, certain current price. Okay, so please, I hope you all get the drift. So let's have some notations for these things. So when we have P0 or P0, P0 represents the price at the base time point. So like I gave this, if you are comparing price of something in January and October, then the price at January is the P0, okay? And then the current price in October, we will call it PN, okay? So PN is the price at some other time point, which we don't know. Any other time point other than the base time point will represent it with PN. The same applies to quantities. If you have the quantity Q0 represents the quantity at the base time period, and Qn makes up the quantity at some other time point. Now, the IP, which is the price index, P representing price and I representing index, and IQ will be quantity index. Okay, so if you put these expressions together, then to find our price index at any period n, okay, at any period you're interested in, other than the base period, it is going to be a price at that period of interest divided by the base price multiplied by 100. And the same applies for the quantity. If you have interested in the quantity index of a certain product, it is going to be the quantity at the new period of interest divided by the quantity at the base period times 100. Please, is anyone lost so far? We are online, UGBS 202. If you are lost, just click on the link and get back into the class. All right, so let's take an example here. It says the price of a quantity of a product A from 2010 to 2014 is as follows. Using the year 2010 as the base year, calculate the price index from 2010 to 2014. So we are assuming that the base price or the base period is 50, okay? Because the question says, let's take 2010 as the base period. Every other period is a new period of interest to us. So starting off, the index number of every base period or at every base time point is 100%, because you're only going to divide that value, the value at the base period, over itself and multiply by 100. So for every base, for every base period, the index number is 100%. If you move to the next period, then this time around we are comparing 2011 to 2010. So it is this now is now PN at 2011. So PN, which is 60 over 50 times 100, will give us 120. Then at 2012, and this another PN, then it's 55 over 50 times 100. Then we have PN. Okay, so guys, I want you to follow PN over 50 times 160. I was hoping that someone would just spit it out, even though. Okay, so in that order, it works in that order. So I guess I should move a little faster. I'm going too slow for you guys, so you are feeling that. All right, so let's look at index and index relative. Now, when you have many products, maybe one or more products, and you're interested in the index number relative to a specific product, we can also compute that, okay, using the same idea. Okay, so if I have, say, a video recorder and a television set, and this is the price, this is the quantity sold, price, quantity sold, so this is a year, this is another year. Now, suppose that we take 2013 as the base year, then this will now become the new period. Okay, so this will now become QN. But if this is the base year, then this becomes P0, and this will be here. All right. So if 2013 is the base year, then for video recorder, the price index is 10.84, meaning that there is an 8.4 percentage point increase. So for the quantity index, we have this and we have 70. Please, what does it mean to have 70? Anyone here can help us? What does it mean to have the index number to be 70?
30% increase.
Come again?
Base 10.
Come again, please. Come again.
30 remain.
30 what?
A 30% decrease.
30% decrease, exactly. So you'll see that in this case, it means that the quantity has dropped, okay, and there is a 30 percentage point decrease in stuff, okay? Because you always know that always the base period will have 100%. So anything added to or anything above the 100 means it's an increase. Anything below the 100 means it's a decrease, okay? Just have that in mind. And then for the television set, we have a 13.4 percentage point increase, and then a 68 percentage point increase in the quantity. Now, we will look at the fixed and then the change-based relative index. Now, if you look at all that we've spoken about prior, it's obvious that, or it seems as if that we always have a certain period, or there's only a specific period that is kept aside as the base period, and we compare all other periods to that base period. Okay, so we want to look at, are there any instances where the base period could also be changed or will be changed? And so we have something we call the fixed based, which you have already seen, and we also have the chain-based relative indices. So for the chain-based and then the fixed base, the difference is so clear. So this one we don't even need to talk about. For the fixed base indices, we identify a specific period, or for some reason, for all intents and purposes of good intentions, we identify a period, and that period is our base period. And then we compare all other periods to that base year. Okay, so in the example you have, look on the top, we have from January to June, we have the production values there. And so we assume that February is our base period. And so we will take each of the period's values.
So please come again.
Which part? Which part don't you understand?
Just as you started.
All right, so for the fixed base period or fixed based approach, we are saying that we have a specific period, one fixed period, against which all other periods are compared. So here, suppose we assume that February is our base period. It means we'll compare January to February, we'll compare March to February, April to February, May to February, and then June to February, okay? We compare all the periods with the base time period, okay? So if I take January, it is this figure over the base value here and times 100, and I get my percentage, my index number. Okay, and then because it's the base period, you get 100 because you're going to get 4245 over 4245 times 100. All right, but going beyond this, if you look at March, April, May, June, they all have different stuff. Please, okay, that one is this is all we're doing also. For the chain-based period, the understanding is that the period immediately before our current period of interest is our base time or our base period. Okay, so for instance, if I am in February, then January is the base period for February. If I move to March, then February is the base period for March. If I move to April, then March is the base period for April. If I move to May, then May is the base period, okay, for April. Please, I saw a hand raised. Is it Kwabena or something? Could you ask a question? Sorry. There was a hand raised. Okay, so maybe he'll come back and ask the questions.
Please, I wanted to say that go over the fixed base relative index again.
By you understand it now, isn't it? Well, you said you wanted to say, it means that you don't want to say it anymore.
No, please. Because you didn't call me, that's why I lowered my hand. But I want you to go over it again, please.
Okay, so look at it here. All we are saying is, for the fixed base, there's one specific period that becomes the base. You remember we said defining the index, the price index, it is the new period over the old period times 100. Is that not it? So here, this P not here is fixed. So here we fixed it in February. So if I'm at January, I want to find the price index at January. It is the value at January, which is the PN, divided by the value at February, okay, which is this. If I'm at February, it is this same value over this same value because that's the base period. If I'm in March, it is 4841 divided by 4245, okay? If I'm in April, it is 4644 divided by 4245. If I'm in May, it is 5290 divided by 4245. If I'm in June, it is 5156 divided by 4245. Is that okay? So here, the base is fixed. If in January, it is 4563 divided by 4245. So you notice that it is the same base across all. Okay, so you have all this for them. For the chain-based approach, we're saying that the period before the new or the current period of interest is our base period. So if I'm in February, then January is the base period for February. It means I am comparing February with January. If I come to March, then February becomes the base period for March. So which means that I am comparing March with February, and it goes in that order. Okay, so here you notice that the base value or the P naught, the base prices, keep changing. They are not the same. Okay, and you would also notice that in January, we are unable to compute the index number for January. Well, because we do not have information from the previous period. So we do not know what the value was in December. So we can compute this thing for an index number for January. However, all the other ones we can compute because in February, I'll use this. In March, I'll use February. In April, I'll use March. In May, you use April. In June, you use May. All right, so everyone understands this? Very easy stuff. All right, so let's try and understand instances where we seek to compare values at different times. Okay, values at different times. Now, we want to compare values at maybe multiple times or two different times. So we agree that the index, the price index, okay, is PN over PO. So let's say this is a future period and PM is PM over PO. Now, take PM to be the current period that we are now. So let's say we are in a current period and PN, let PN be a certain future period that we are. Now, ideally, because the fact that we have the chain-based period, we still prefer using the fixed base period because it's changing the base periods comes up with certain challenges. These are the challenges with continuity, making comparison more meaningful. For instance, someone gave an example in the previous lesson that in Ghana at the moment, all our comparisons are made based on the terms on which political parties come to power. So if NPP is in power, they will compare all these indices based on when NDC was in power. If NDC is in power, they compare it based on when NPP is in power. And it doesn't really help our our system. However, my little knowledge when tracking these index stuff, our first base year was in 1960. That was when we attained our independence from our colonial masters. And it was used from 1960 all the way to 1992. Now, another significant period, in 1992, we had moved into a new dispensation, or let's say a more democratic dispensation, moving away from the dictatorship into democracy. So the base period was changed from 1960 to 1992. So whatever happens over a certain time period, all we do is to use the fixed-based approach or the fixed-based period. So if you look at these two expressions, there's one thing that is common to both of them. That is the base periods. Okay, so let's seek to make because the base period for M will be the same base period for N. Okay, so let's seek to make both of them the subjects, or we can equate them to each other. So if I make these the subject, okay, we can have Pn, okay, over IPn. Okay, I'm trying to skip the steps, that's why. And if you have the other one, you would have PM over IPM, okay? So we are kind of like saying that P naught here for M is the same as P naught here for N. And of course, it's the fixed-based fixed-based approach. So the base period for M will be the same base period for M. So we can equate these two. Okay. Now, for those of you who don't understand what I did, all I did was just cross multiply. Okay. So this and that. So this is going to be IPN times PO equals PN. And because I want to make PO the subject, I'll divide both sides by IPN. Okay. So PO equals, okay, over that. Okay, so you just divide both sides. You just divide both sides by IPN, and PO will stand on this one. So this will be PN, and this will be IPN. So that's why we have PN over IPN. So the base periods are the same for both, so we can equate them. So we can have an expression that has PN over IPN equals PM over IPN. Okay, so suppose that we have such information as this. We have the month, 7 months, and then their respective PMs. What's it called? Indices. Okay. Now it says that if sales in month 3 amounted to 240 units, what was the sales value in month 8 if the index is estimated at 109? All right. So see month 8 as N, that future time period, and month 3 as M, okay, as the current period, So we do not know the sales in month 8, okay, but we've been given an estimate of the so let me just call it month 8 over 109 equals, then the sales in month 3 is 240. And then the index in month 3, here, this is the index in month 3. So you have month 8. Guys, help, let's go ahead. I'm waiting for you. You have month 8 times 98. Okay, would be equal to 240, 109. I just want your involvement, that's all. Okay, so when I pause, I expect someone to just say.
I divide through by 98.
Exactly. Thank you. So you have month 8, which will now be 240 times 109 over 98. Okay, so when we did it, we had okay.
6, 7.
All right, thank you. All right. So there's another point. This thing, I don't have to waste time on this. We call this the percentage change period. So percentage change is the amount of, it's just like you computing the rate of change, okay? So if you take a certain, if you take the base period, let's assume this is the base period, 100. Period 1 and period 2, 120 minus 100. Okay, so you have a 20 percentage point difference. It just goes, if again you take period 1 and period 4, you have an 8 percentage point. If you have period 1 and 5, you have 35. That's just how this thing works. All right, so now let's also try again and understand. Okay, so why would the base period be changed? Well, what's the issue with changing base periods? Well, oftentimes when you use the base period or the base year for a very long time, your indices begin to have, would end up having some very huge values that will not necessarily begin to make sense because the values are compounded over the years, okay? So for instance, if you have, let's say, an index that has grown so big to 5,000, if you have a 10% increase or 10 percentage point increase, you're going to have like 5,010 percentage point. But you have an index that has grown to like 10,000, you have 10,010. It doesn't really make what's it called, so much sense when it comes to stuff. And that 10 would, if you find the actual percentage difference, is going to be like so 0.2% or something. So oftentimes we are interested in, if we're interested in making the information more sane and more concise, understandable for people, then when the indices become so large, we change the base period, scrap everything off, and then we start all over again. Okay, and also when some significant issues happen, it's also another reason to change. Like for instance, in Ghana, when we attained our independence, we had our base year. And when we moved from the tyranny of our dictators, we moved into the democratic era. And so there was reason enough to change it. I once heard before that when we entered the millennium, there was reason to change it. I am not sure if it's been changed, okay? But, well, or maybe when we entered Y2K, it was changed or something. However, changes that occur in the base periods introduce issues of discontinuity, and then it makes it difficult to make some comparisons. So like a typical example is to say that, typical example is to say that when we have a certain political party in power, they would compare performance against the immediate past period. And you hear it on the radio all the time. When we did this, the city was, why can't you compare the city to what it was when it was in 1992 or what it was when it was in 1960 or something? Then you can see how powerful the city was and all that, but we don't really see it. So it makes it difficult to, it makes your comparison quite shallow. You're either comparing only within a certain period, or you are so limited so that you don't even compare beyond certain periods at all. Okay, so these stuff do happen. All right, so now let's again try and understand the case when we have a change in business. Now, please don't worry too much about all these things that I'm doing. It's just for you to get a certain understanding into what it means by the base changing and everything. You see, the computation is so simple. You don't even need to have lots of ideas about these things. Okay, so think about it this way, that some time back, we had our base period in 1960. Then we changed it in 1992 forward. So all the years between 1960 and 1992, we must use the base period 1960. And all the years between maybe 1992 and now, I don't know what the current base year that Ghana is using now. I don't know. There was one time I also heard that I think in 2000, was it in 2007 or something? When
2006.
2006, yes, when we became what's it called? It's a middle income something. It's an upper middle income economy or something.
Middle lower.
Yeah, middle lower. Yes, yeah, I understand. Yes, I remember. Yes, they changed our base year to that kind of distance. So we became a middle lower income country or something. Yes, I remember. Yeah. So I think that's I think that's the current base year they're using now. So now let me make it a little more clear. So let's say 1992, okay, and then 2006. Yeah. So between these periods, we would use this base period, and between any period between now 2021 and 2006, we should use this base period. So if we are comparing these two, this is an old, okay, index period, okay, an old index period, and we can call this as a new index period, okay. So if we are using the old index period at n, if you're using the old index period, then we would use the value, okay, at what period n, value at period n we are interested in, okay, divided by the old base value. So even if you're interested in let's say in 2010, okay, but we want to compare it to what was happening in 1992 thereabout, then you can take the value at 2010 or maybe production value at 2010, but you must use the index value at 92. Okay, so this will give us the old index period value, and the same applies to the new. If you are using the new index period, then you must use the value at period n, okay, divided by the new base value. So with this, you see, we can compare something in 2020 to something that happened in 92, or to what the situation was in 92. Then we can also take something in 92, okay, and compare it to what is happening now, okay, and use the different base periods and make that comparison. So we can have with this, so the old base value, okay, the old, so here, but there's just one thing that is common to both of them. Both of them have base values, okay, base values. So here we are interested in, let's make the base values the subject, okay, because that is the only thing, because for the periods they are different, the indices at those periods are also different. So we just take the base values. So here we can say that if we make the base values the subject, okay, then we can have the value in a certain period over the old index, if it's the old index we want to use, and then the value in the current period if we are using the new index. So we can have value for this and that. So if we take a ratio of the old base value and then the new base value, okay, it's like dividing this guy and this guy, like this, old base value over new base value. You're going to have something like this, this divided by this. So this is the same as, like, this will now multiply new index, okay, at period n over, okay, value in period n, okay. So because we are interested in the index, okay, we already have the base values, we cancel out these ones. So we end up having the new index values and then the old index values multiplied by the old base values over the new base value. Okay, so I know this thing doesn't work so well, but now we are not even using what's it called, stuff as in variables or decision variables, so it makes it a little, but just look into the intuition here, that here we have value in period n over new index in period n, value in period n over old index in period n. So you see that here, with these two values, this and this tend to be the same, because that's like, hypothetically, we are interested in a certain value at a certain point, a certain value at a certain point. So these are the two elements that would seem to be the same. But here, these are not the same. Old value at period N, and then old index at period N, and new index at period N. So, this and that would cancel. Then you now have new index at period N over old index at period N. So our old base value over new base value would be equal to new index at period N. That is if we are doing it for M. So this is when we do it for N for nanny goat, and this is when we do it for M. Okay. So if we have these two, then we can compare the two. We can say that the new index at period N over the old index at period N can be equal to the new index at period M over the old index at period M. Okay, so therefore, in comparing between the old indices and then the new indices, we make the comparison as such, like this, okay? So we take the old index at period N over the old index at period M, and then the new index at period N and the new index at period M. All right, so let's just take a practical example and then you'll see something about this. So first, let's look at the case when we are using only one index. Please, only one fixed index. Don't worry. It says that the following indices is relative to the base year of 1975. Suppose the base year is changed to year 204. Calculate the new indices using the new base year. So we have all these values here, but these values were calculated based on the index in 1975. So now, if we want to change it to 2004, we will now need the new value, okay, the value at 2004, use it to compute what is it. We are no longer going to use the value at, what's it called, 1975. The value at 1975 is the index at 1975 is 100. If we find the index at the new index at 204, it will also be 100. Now, because the value at 204 is now 324, we are now going to use 324 as the fixed base to calculate the index for all of these. So now, if we did this over itself times 100, you get 100. So the index number for the base year is always 100. In 205, we use this as the base period divided by this, and we have 108. We do the same, we do the same, we do the same. So here, you notice that, so this is just the first instance. We are taking a new index, okay, and we are finding the index based on values from a certain old time frame, okay? Now, let's combine the two. Look at a question like this, where let's say we have an 8-year period. We started with the index in year 1, okay? That's 1. All right, so we started in year 1, okay? And when we go to year 5, we changed the base year. So the base year was in year 1. Then when we go to year 5, it was changed. So now we will use the new base, the new index value to calculate the indices. Now, so it says that if the company had not changed to index 2, what values would index 1 have in year 6? So now it's like saying we are in the new era, okay? But we want what the equivalent indices would be, okay, if we had not changed to this new one, meaning that we are supposed to use the old, what's it called, index. Let's go back. So if we are doing this comparison, then it says that now, it means that we will need the new index at period N, okay, divided by the new index at period M. So period N is a certain period or future period or the current period of interest, and period M is like the old period. Just think about it like let's say maybe N is like the future we don't know. M is the now that we know, or something we know some information about. Okay, so here, what this is saying is, so in this instance, we need to find here for these ones. So we will take the new index divided by the old index, okay, and multiply by M, which is the index that we know, which is 125. So here it is just that straightforward, 230 over 100 times 142. And then again, 230 over 100 times 160. Okay, and so new index at period N, okay, over index at period M. So here we assume that this is M, the old one that we know, or the one that we know about. Okay, multiplied by this, and then we find our value. Okay, so you do this and you find the reverse. Now, it tells us now what values does index 2 have in years 1 to 4. What this is saying now again is telling us that now we want you to track back. Now, we are now at index 2, meaning the new index here. Okay, the new index. Now, you are to compute the new index, okay, comparing it with the old index. So here, we are just saying that we are taking, if you go back to the expression we had, if we come here, we will now have to look for the old index at N, and then the old index at M. Okay, so here we are saying that the old index, which is 100, over now, because this we are now this becomes the new one that we are computing. This becomes the old index that we have. So it's 100. Now it's more like the reverse. Go back for what you used to use, and then divide it by the new one that you have brought, and multiply it by M. So we take the first one by 100. It will give us this. We will now take again 100. Oh, sorry, it's 230, not 200. Forgive me. 230 times 140. Then you have again 100 over 230 times 168. Then again 100 over 230 times 199. So with this, it gives us the values for the index 2. Okay. All right. So we kind of like try to solve it here. Yeah. So index 2 of the year times this. So we go to index 2 of that particular year. Then we take it over the new index over the old index, the new index over the old index. And when we move back to the old index, it is the old index over the new index times the index of the year of interest. The old index over the new index times the old index of the year of interest. Okay. Chris, how much time do we have? There are like 4 more concepts I need to do. Jeez, Chris, when are we supposed to end? 12, right?
12.
Yeah.
Okay.
Yes, please.
Please, forgive me. I'll be a little fast, but if you don't understand, just draw my attention. A little fast, not fast. A little, but it does. I'm not saying I'll stop going fast. I said when you don't understand, draw my attention. But it means I'll still go fast.
Okay.
All right, no problem. All right, so let's look at the case when we are interested in finding the indices of more than one variable. Okay, so suppose that I have 1 or 2 variables or 3 over a certain period. We can find their combined indices. And normally this is what you get when we do the consumer price index. When they say you take a basket of commodities. So if we're interested in finding the indices for, let's say, vegetables, we can take the most bought vegetables, tomatoes, onions, pepper, put all of them together into one basket and then find their aggregate stuff or their simple mean relative. Let's just see how it works, like straightforward. For the mean relative index at period N, it says sum of the separate indices at period N over the number of indices. So what this means is that for each of the items, so let's say tomatoes, onions, carrots, we have their values. Find the index of this. So it's like maybe you have 101.5, this is 110, and this is 120. Okay, what this means is that you sum all these and divide by the number of indices, which is 3. So the sum of the individual indices divided by the number of indices will give you like an average indices, okay? However, in the case of the simple aggregate relative index, what it does is for you to rather sum the actual values over the period and divide by the actual values of the base period and multiply by 100. Let's look at it here. So let's say we have 2013, 2014, 2015, okay? And we have coffee, tea, hot chocolate. These are the 3 items. So the price of coffee in 2013 is this. In 2014, these are the prices. In 2015, these are the prices. So let's assume that 2013 is the base year. So this is the base period. Now let's find the indices or the price indexes or price indices for 2014 and 2015. So we will take, so we know that the price indices is Pn over Po times 100. So this is the current period, Pn, divided by the base period times 100. So we have this. So we'll do for all 2014 and we'll do for all 2015. So to find the mean relative index, we will sum this plus this plus this. And there are 1, 2, 3. So just like taking the average indices, that is the mean relative index. So we sum this and then the average is 109.9. Okay. The same for 2015, we sum and we take the average and we have 97.7. Okay. If we are computing it if you're using the simple aggregate relative index, the word aggregate is what makes the difference. So aggregate and find the index. Okay, so what it's saying is that it's like you're still going to do Pn over Po, but this time around, you're going to put all this together, sum all this to give you one composite value, okay? And divide it by the sum of all this again to also give you one composite value, okay? And then you multiply by 100. So here, you do 62 plus 32 plus 74, all divided by 55 plus 28 plus 72. Then you multiply by 100, and then it gives you the index number. Then we also do for 2015, we sum all this to give us the Pn, and we divide by the sum of everything at the base period, okay? And we'll get 92.9. Okay, please, are we okay? Is anyone confused here? Anyone? All right, so perfect. So everyone understands this one. That's why I like you guys, all elective math students. You're perfect. All right, so the mean, okay, the 2 approaches that we just spoke of, they have their fair share of challenges. Okay, so we try to kind of like augment them. So there are some processes, and then these are some of the reasons why we have some disadvantages of this. You have certain products that their prices are so high, and there are some that their prices are so low. And if you put them all together in one basket, we don't get to really see the difference. And it makes a little bit of sense. Now, for instance, if I were putting water, okay, let's say we are looking at household essentials, essential stuff in homes. And then water, even up to today, a gallon of water, like when you go and fetch water, maybe a bucket of water or something could cost like 60 pesos, 50 pesos. And you will buy, what's it called, the charcoal, a bag of charcoal for like 200 cedis or 300 cedis. You know, these are all essential, but comparing charcoal and water is more valuable than this. But when you do this, what is the aggregate, the simple aggregate, or this, they just lump together all the things and just put them all together, and you just kind of like have one composite, and that doesn't really give you the true picture of what the things that are entailed in it. The simple aggregate, yeah, the mean one as well also has, you don't get to see which value or which of the items is contributing a higher change in price compared to, so for instance, if we did, so if we let's say you had, we have milk and milk and something, and let's say cheese. Milo gave 170 point maybe 5. Milk is 110.2, and cheese is like 101. When we sum all these and you take the average, how can you tell someone with that average that, you know, Milo is really expensive? When household items, like, you can single it out and get to see. So we don't account for the real changes that are happening in business. So it's like it gives a certain blanket kind of view of the stuff. So we have a way of looking at things from a certain way that we try to kind of like apply some other approaches that would see where the differences occur. We can account for those differences and say, okay, so if there is something significant happening here, we want to account for that significant happening. If there's something insignificant happening here, we also account for that insignificant situation there, okay? Then we can put it all together and then have a fair idea. So then another challenge too would also be when you have mixed units, when something is in kilograms and something is in grams, something is in milliliters, some is in gallons, all this. And then because you are taking the simple mean or the aggregate, you're putting it all together and just boom. It's not a fair comparison. You must always try, you compare apples with apples, oranges with oranges. You don't mix apples and oranges and compare them. It doesn't give you a meaningful comparison. Okay, so how do we account for these problems? We use some approaches we call the weighted indices, okay, where we attach importance weights to the commodities or even the indices, so that if something has a high weight, it means it is very important, or it has something significant, or it's making a significant contribution. When it is not making any significant contribution, it also has a lesser weight, okay? So, for instance, if you have a commodity that has, the price is 2 cedi, you have a lot of people buying the stuff, like 20,000 people. Then you have something that is being sold for at 1,000 cedis, and you have only 2 people buying it. Now, if you base this argument on a simple aggregate price or quantity index, you yield the results that ignores the size, or when I mean the size, I mean the quantity and then the price of the commodity. It is obvious that if you're buying a gold necklace, okay, and then some fake polished gold dust necklace, the differences will not be the same. You will have like 200 people buying the gold dust, the necklace that is the imitated gold one, and you have very few people who can really afford. But in these instances, we want to know what is the volume, or what is a significant contribution to those buying the fake one and then those buying the original one, so that we make certain decisions on stuff. Okay, so we have 2 weighted indices approach. We have the weighted mean or relative index, and then we also have the weighted aggregate index. So we are only building on the weights, what we just saw, the relative mean index and then the aggregated mean index. The only difference is now we are going to add weights to them. So all we are saying is, for the weighted mean index, after you have found the indices, okay, after you found the indices, we attach individual weights to the indices, okay, and then we divide by the sum of the weights. For those of the aggregates, we attach weights, okay, to the values, or the whatever values that we have, okay, and we aggregate them and do the stuff. So the difference here is just that now we are introducing weights. So for instance, let's say that we have the price in year 1. Okay, so you have year 1, and these are the prices. And in year 2 or PN, we have these prices, and we have the weights. Okay, so this is the price in this period, and that, and that, and that. And you have the weight. So it says calculate the mean weighted mean price index, and then the weighted aggregate index. So here, if we take the mean weighted, we first take the first one. So here you take 24 over 20 times 100, this over that, this over that, this over that, and you find the indices. So these are the indices. When you are done, you multiply each index number by the weight. Okay, so by the weight, 120 by its weight, 192.73 by its weight, in that order. And then when you are done, okay, when you are done, you sum them, sum all these, and divide by the total weight. So the total weight, 8 plus 6 plus 4 plus 1, so 6 plus 4 is 10, 8 plus 1 is 9, 10 plus 9 is 19. So the weight is 19. So we'll divide all this by 19, and we'll have 115.56. Now, what this has done is to account for the differences, the differences in the weights, in the contributions of each of the elements here. If we go to the second one, which is the, how do you call it? The aggregated one. First, you take the PNIs. You take the PNI, okay, so here, you first take, you remember, it has to be PN over PO. So you first take this, multiply by the weight, this multiply by the weight, this multiply by the weight, okay? And when you are done, you also take this, multiply by the weight, multiply by the weight, multiply by the weight, multiply by the weight, and then you divide both and you do it over 100, okay? So here, what we have done is we'll do WI times PNI is here, we have this 704, then W representing the weights times the PUI. So each of the base period times its respective weight. So we have 704 over 627 times 100%. And then you have this 122.20, okay, for the weighted aggregated mean index. Okay, then we also have two special indices, which we call the Pache index and then the last Paye index. We have both last Paye quantity index and then last Paye price index. And we also have the Pache quantity index and the Pache price index. So let's see how it works. In this one, when you take the last Paye index or price index, then the quantity, okay, at the base period is used as the weight. Okay, so here we say we have PN over PI. Now, the quantity so we will have something about the prices, and then you also have the quantities, okay? So the quantities at the base periods would be used as the weights. So you multiply the quantity by the PN for all of them, and then when you are done, you give you. Then when you are computing for the quantity index, you do the reverse. The price value at the base period will be used as the, what's it called? The weights. Okay, so for instance, if we have an item, we have two items, A and B, P naught, PN. So this is the price at the base period. This is the price at the certain period. This is the quantity at the base period and the quantity at the new period. So to find this, we will take, if you want to find the price index, it is going to be, now this at the numerator, you're going to take this guy and multiply by this guy multiply by this. okay, and sum it, and divide by, again, this guy multiplied by this, and this guy multiplied by this, and sum it and multiply by 100, and it will give you your price index. If you are computing the quantity index, then this time around, the price at the base period becomes the width. So now it is going to be this guy multiplied by this guy multiplied by this, okay, at the numerator, divided by, again, this same one multiplied by this, plus this one multiplied by this. And then you will do it and you would find your stuff. So see, very easy. You just need to last pay quantity. Okay, when it's price index, the quantity at the base period is the width. When it's quantity index, then the price at the base period is the width. Then the second one, which is the per share index or current weighted indices. So for the current weighted indices, because this current here, what it's trying to tell you is that the current price, the PN, so if you are looking for the per share price index, then the PN is the width, okay? And if you're looking for the quantity, so here you use the current quantity as the width if you're finding the price index, and you use the current price as the width if you're finding the quantity index, okay? So when we come here, so let's say this is the number of units, we'll call it quantity, and this is the price paper, we'll call it price. This is year one, this is year two. Let's assume year one is the base period, okay? Year one is the base period. So you want to find the per share price index. So here, we are saying that here, the current quantity is the price, is the width. So if you're finding price index, then here, if this is the quantity, this is also going to be Qn, this is Q naught, okay? This is going to be P naught, this is going to be Pn, okay? So if I'm finding the price index, then I'm going to multiply this times this, plus this times this, plus this times this, plus this times this. So all this will be the numerator. So you're going to do 24 times 11 plus 51 times 25. Okay, then you do all the way to 34 times 20. When you do it, so that is the numerator. Then you come to the denominator. The denominator is now the base price times the current quantity. Oh boy, so I clean it. So here I am going to have okay, so let me do a little for the top, you're going to have 11. So 11 times 24, okay, plus 51 times 25, plus 84 times 17. Let's assume they're only 3. And then the last one you can add it to. And then for the bit, which is the P naught, okay, you're going to have Qn. So this is, so you're going to have 10 times 24. So you have 10 times 24, okay, plus 23 times 51, okay, then plus 17 times 84, okay, and you do for the last one. So when you are done, you do everything then times 100. So if you are doing it for, this is for the price index, okay, but if you're doing it for the quantity index, if you're finding the quantity index, okay, then this time around, you're going to have your new price to be the width. Okay, so, okay, so here, this is the quantity index here. So this here is the width now. And so you take the first one, you're going to do 11 times 24, this times that, this times that, this times that, plus now you're going to take Q naught. Now you're going to take again this same one and multiply by this same one, okay, and divide by and do times 100, and you are done. Okay, so this is the per share and yes, per share price index, per share quantity index, Achieve last pay price index and last pay quantity. So you can even use just this table. You can use this table to solve all of them. It says yes. So calculate base weighted quantity index. When you say base weighted, just know that the base period is the base value is the weight. So if it's price index, then you use the base quantity to be the distance for you, the weight for you. If it's quantity index, you use the base price to be the weight. Now, if you're doing the current weighted one, which is the Pache index, current means the current price, Base is the base price or quantity. So here, if you're doing for price index, then you're going to use the current quantity as the weight. If you're doing for quantity index, you are going to use the current price as the weight. This to be all understand. I pray you just sit back and
No, sir.
go through it and